So good morning friends. Today we'll see a summary of Radix to DIT FFT algorithm. So in the last lecture we have seen DIT FFT for n is equals to 4 point and for DIF FFT for capital N is equals to 4 points. Now here we see how to draw this flow diagram for Radix to DIT FFT algorithm. So let me take the pointer option. Now the first point is what? The number of input samples capital N is equals to 2 raised to m, where m is an integer or it is equals to number of stages. I have told you earlier, when capital 8 is equals, so capital N is equals to 8, so it can be represented as 2 raised to 3. That means to have a 8-point DFT, we require what number of stage? We require 3 number of stage. So we have seen for capital N, we have already seen that we are having 2 number of stages, so 2 raised to 2. So this power indicates number of stages for a particular flow diagram. Now the input sequence is shifted through bit reversal order. So I have told you for DIT FFT algorithm, the input sequence is in bit reversal order and the output sequence is in natural order. Now the number of stages in a flow graph, I have already told you that m is equals to log to the base 2 of n. So it can be for capital for n is equals to x, so log to the base 2 of 8, so that value is equals to what? That value is equals to 3. Okay, so by this formula also you can calculate the number of stages in a flow graph. Now each stage, now here we are having 3 stages. So for capital N, here we are having 3 stages. Now in each stage consists of n by 2 butterflies. So let me take you one example. Capital N is equals to 8. Now in stage 1, what will be stage? In stage 1 will be having 4 butterflies. In stage 2 also will be having 4 butterflies, and in stage 3 also will be having 4 butterflies. So in each and every stage will be having 4 butterflies for capital N is equals to 8. If capital N is equals to 4, so for each stage will be having 2 butterfly, and for the second stage also will be having 2 butterfly. Now the input and output for each butterfly, are separated by 2 raised to m minus 1 samples. 2 raised to m minus 1 samples, where m is equals to stage index, that means the number of stage. You consider for stage 1, you consider the stage index as 1. For stage 2 it is 2. Now let me tell you one example. So see here, so the input and output is separated by 2 raised to m minus 1. 2 raised to m minus 1. Now you consider capital N is equals to 4. Now if you are considering capital N is equals to 4, then stage will be what? Stage will be 2. So m is equals to 1, that is my stage 1, and m is equals to 2, that is my stage 2. So input and output are separated by, so here 2 raised to 1 minus 1, so 2 raised to 0, that is equals to 1. So here input and output are separated by 1. The input and output are separated by what? The input and output are separated by 1. For capital M is equals to 2, 2 raised to 2 minus 1, so 2 raised to 1, that means it is equals to 2. The input and output are separated by 2. So let me tell you example. See here this is my input and output. So here input and output, you consider only this part. Okay, you consider only this part because I have taken the example of 4. The input and output are separated by 1. Here it is separated by 2. See, here it is separated by 2. Okay, the input and output are separated by 1 for stage 1, and for stage 2 it is separated by 2. For capital N is equals to 4. If capital N is equals to 8, then the input and output. See, this is point number what? This is point number 5. The input and output for each butterflies are separated by what samples? Okay. So for n is equals to 8, the input and output for each butterfly are separated by. You take the example of m, it will remain same. Here it is 1, here it is 2, and for m is equals to 3, it becomes, because we'll be having 3 stages for capital N is equals to 8, so it becomes 2 raised to 3 minus 1, so it is equals to 2 raised to 2, that is equals to 4. Now let me show you how it is going to separate. So for n is equals to 4, it is separated by, for stage 1 it is separated by 1, for stage 2 it is separated by 2, and for stage 3, when you are considering capital N as 8, it is separated by 4. So 1, 2 and 4. So let me show you here. So input and output, see here, the input and output are separated by, for each butterfly, so this is my first butterfly, so it is separated by 1 sample. Initially we are having 1, and here it is next 1 samples. Here you consider, so 1 butterfly it is completed here, you see this direction, 1 butterfly it is completing here, so here 1 sample is already there, and it is separated by these 2 samples. Here it is separated by what? 2 samples. Now to complete this butterfly diagram, see here, this is my butterfly. To complete this butterfly diagram, it is separated by, already initially we will be having these samples, so 1, 2, 3 and 4. So each butterfly is separated by 2 raised to m minus 1 samples. So here it is 1 samples, 1, 2 samples, and 1, 2, 3 and 4 samples. So complete, see, this is the butterfly diagram. If you see here, I am showing as a red path. So after completing each butterfly, initially we are having here first samples 1, 2, 3, 4. So 4 samples. Each butterfly consists of 2 raised to m minus 1. So here it is 4 samples, here it is 2 samples, and here it is 1 samples. Now let me tell you, now this is very important. I have told you what is the need of FFT if we are having DFT. So for DFT, here you require n square complex multiplication and n square minus n complex addition. So here the number of complex multiplication is given by n by 2 log to the base of 2 and n log to the base of n log to the log 2 of n. So that is complex multiplication, and here it is the complex addition. So when you compare, obviously it is very less as compared to the direct computation of DFT. Now the point number 8 is very important. The twiddle factor exponents, I have told you, after completing each butterflies we need to multiply with twiddle factor exponents. So twiddle factor exponents is applicable for stage 1, stage 2 and stage 3. So twiddle factor exponents are the function of stage index. I have told you it is applicable for stage index, and it is given by k is equals to nt by 2 raised to n, where value of t is k is equals to nt by 2 raised to n. So let me draw this. K is equals to, so this is very important, k is equals to nt by 2 raised to n, capital N, this is capital N, nt by 2 raised to n, where range of t is valid for 0 to 2 raised to m minus 1 and minus 1. So k is equals to what? K is equals to nt by 2 raised to m, where the range of t is 0, 1, 2, 3 up to 2 raised to m minus 1 minus 1. So where m is what? M is stage index. So let me tell you for capital N is equals to 8. So it will be more clear. So here capital N is equals to 8, and you consider first as stage index as 1. So if I am considering stage index as m is equals to 1, so the formula for k is, and the twiddle factor exponent is known as Wn k. This is the twiddle factor exponents, Wn this k. So k formula is known, n, value of n is known as 8. The range of t is not known, we have to calculate. And 2 raised to m, so stage is what? Stage is 1, so 2 raised to 1 is equals to 2, so it is equals to 4t. And what is the range of t? So range of t is 2 raised to m minus 1, so t is equals to 0 to what? We have to calculate. T is equals to 0 to what is the value of m? The value of m is equals to 1, so 2 raised to 1 minus 1, so 2 raised to 0, so 2 raised to 0 is 1, so 1 minus 1 0, so it is valid for 0 to 0 only. It is valid for 0 to 0 only. 2 raised to here, because value of m is equals to 1, so m is equals to 1. 2 raised to 1 minus 1, so 2 raised to 0 is 1, 1 minus 1 is 0. So here we will be having only the one value for k, and it is value for t is equals to 0. So the value of k is equals to 0 only. Why? Because we have got the range of t is applicable only for 0. So 4t is the answer for k. So while putting t is equals to 0, we will be getting k as 0. So that's why we have to multiply Twiddle factor exponents W8 k. So W8 0. So that is the Twiddle factor exponents we are going to multiply for stage 1. Now let me tell you example for stage 2. So m is equals to 2. So the formula k is known. You first find the range of t. So t is equals to 0 to 0 will be there, 0 to 2 raised to m. So 2 raised to m minus 1, so 2 raised to 2 minus 1, so 2 raised to 1, so it becomes 2 minus 1, it becomes 1. Here you put m minus 1, so 2 raised to 2 minus 1, so that means 2 raised to 1, so that is equals to 2 minus 1 1. So here range of t is valid for 0 to 1. So we have to find k is equals to, so we have known the k is equals to 8t, 2 raised to m. So what is the value of m here? Value of m is equals to 2, so 2 raised to 2 is what? 4. So we will be having 2t. We will be having what t? We will be having 2t. So you put the t is equals to 0, we will be getting k is equals to 0. Okay, and when I put t is equals to 1, when I put t is equals to 1, we will be getting 2 into 1, so 2. So the range of k is what? 0 and 2. So the range of k is what? 0 and 2. So that's why we are getting Twiddle factor exponent W8 0, and we will be getting W8 2. Okay, this much Twiddle factor exponents we are getting, this much for stage 2. Now let me show you for stage 3. So for stage 3 here, you consider m is equals to 3. So range of t is valid for 0 to 2 raised to 3, 2 raised to 3 minus 1, so 2 raised to 2, it becomes 4 minus 1 3. So the range of t is valid for 0 to 3. And now you find k is equals to nt. So 8t divided by 8t divided by 8, because 2 raised to 3 is there, so we will be having t. So what is the value for k and value for t? It will remain same. So the range of t and range of k here both are same. Okay, so range of t and range of k both are same. Why? Because after putting the value we are getting k is equals to t. So the Twiddle factor exponent is valid for W8 0, W8 1, W8 2 and W8 3. These Twiddle factor exponents we require after completing each butterfly. Now let me show you here, and at what number of times these Twiddle factors are going to repeat, I will be telling you in the next stage. See here, these are Twiddle factor exponents W8 0, W8 0, W8 0, W8 0. So this is for what? Stage 1. As you can see here, for stage 1 we are having only W8 0. For stage 2 we are having W80, W82. So W80, W82, and I will be telling you for how much time these dual factor exponents are going to repeat. W80, W82. Here it is repeating for 1, 2, 3 times. Here it is repeating for 1 times, and here there is no repetition. For stage 3 it is W80, W81, W82, W83. So in this way we need to calculate dual factor exponents. After completing each butterfly, we need to multiply with dual factor exponents. So that is my stage number 8 or step number 8. Now number of section or sets of butterfly in each stage is given by number of sets or section of butterfly in each stage is given by. Now let me consider for capital N is equals to 8. So when N is equals to 8, 2 raised to 3. So capital M is equals to what? Here capital M is equals to 3. That is the maximum stage number. Capital M is the maximum stage number and small n is the particular stage number. For that we are doing the calculation. Now you consider for stage 1 here. So for when I am considering for stage 1, 2 raised to 3 minus 1, so it becomes 4. So number of sets or section of butterfly in each stage, number of sets or section of butterfly in each stage is given by 4. For stage 2 it is given by 2 raised to 3 minus 2, 2 raised to 3 minus 2, so 2 raised to 1, so it becomes 2. So it becomes what? It becomes 2. So number of sets or section, that means how much sets are there in the stage 1, how much sets are there in stage 2, and how much sets are there in stage 3. So for stage 1 we have got it is equals to 4. For stage 2 we have got it is equals to 2, and for stage 3 it is 2 raised to 3 minus 3, so it is equals to 2 raised to 0, that is equals to 1. So we will be having only 1 sets in that particular stage. So let me show you here. So see here we are having sets. So this is my first set. So 1, 2, 3, 4. So we are having here 4 sets. You consider this as a single set. So this is my 4 sets or section. Here this complete I am showing this as a 1 set. Okay, so we'll be having another second set here. So here we'll be having 2 sets or section, and here we are having only 1 set or 1 section. So in this way we need to find the number of sets or section of each butterfly consists of 2 raised to capital M minus M, where capital M is the maximum stage number and the M is the particular stage number. For that we need to find the sets or section. So for set 1 it is 4, for set 2 it is equals to 2, and for stage 3 it is equals to 1 only. Now let me show you here the exponent repeat factor, that is known as ERP. The exponent repeat factor, which is the number of times exponent sequence associated with M is repeated and is given by 2 raised to M minus 1. The exponent repeat factor, which is the number of times exponent sequence associated with M is repeated and is given by. So I have told you that the dual factor exponents is repeating for what times. So here it is 2 raised to M minus 1. So we have already calculated 2 raised to M minus 1. So for stage 1 it is equals to 4, for stage 2 it is equals to 2, and for stage 3 it is equals to 1. So I will be showing here. So dual factor exponents, that means this. So it is repeating for 4 times for stage 1, it is repeating for 2 times. Here it is 1 and here it is 2, 1 and 2. So it is repeating for 2 times, and here there is only 1. So 1 is there, 1 and 1. So W80, that is single, W81, that is a single, W82 single, W83 also it is single. So in that way we need to calculate the number of times the twiddle factor exponents are going to repeat. And the last stage is what? Output sequence is in natural order. So for DIT, I have told you earlier, the input sequence is in bit reversal order and the output sequence is in natural order. So in this way we can find the radix to DIT FFT algorithm for capital N is equals to in the power of 2. Okay. Now in the next we have to see DIF FFT algorithm.